Good afternoon, class. My name is Jorge Franco,
I'm Kristopher Chung.
I'm Alfredo Bender.
and this is our project in slider crank mechanism analysis. For the overview, we're going to have an introduction. We're going to talk about mechanism analysis for a slider crank, and we're also going to talk about for a 4-bar mechanism synthesis. And a slider crank. A slider crank is an arrangement of mechanical parts designed to convert linear motion to rotational motion. A slider crank has 3 parts. First part is a crank, the second part is a slide, and the third part is a convention rod. A slider crank for industry application, we choose a windshield mechanism. This mechanism was created by Robert Williams on March 10, 1927, and this is mostly used in automobile, train, and airplane industry. For a 4-bar mechanism, has 4 parts called bar or links. These are connected in a loop by 4 joints. For our industry application, we pick a door closure. This mechanism is mostly used for safety reason and energy saving. On a building, when a fire occurs, this door closes automatically, preventing the flame and smoke to go out. Also, this mechanism is used to maintain the same temperature at all the times because the door is going to be closed always. Now Alfredo is going to talk about description of the mechanism of a slider crank.
Hello, my name is Alfredo Bender. I'm going to talk about the description of the mechanism for the slider crank. This mechanism is the most commonly used mechanism in the industry. It displays both linear and rotational motion simultaneously. It contains a connector rod attached to a crank, and at the end of the rod, it moves in a circular motion, and the other rod, the other end, moves in a linear pattern most of the time. For the position analysis, these 2 tables represent our data, which are given for our project, and the unknowns that we need to find are R1 and theta 3. This is the slider crank mechanism. I'm going to calculate or to analyze the motion. We want to create a loop equation. I'm going to create a loop equation. We need to find the RP vector, which can be represented to that formula over there, which is the summation of the 2 vectors, R2, R3, and R1 plus R4. And by doing some calculations and some simplification, around rearranging the equation, we can find this equation, which will lead to the answer of our unknown R1. A and B are these 2 equations which we have all the data to calculate those terms. In order to calculate R1, we use the quadratic equation, which is this one, and then we will have 2 answers, which will be our 2 closures. And those 2 closures can be represented to this figure right here, for closure 1 and closure 2. And then after we find closure 1 and closure 2 for R1, then we can plug it in this equation to find theta 3, which will have 2 answers. 2 answers will belong to closure 1 and closure 2 respectively. Now I want to talk about the trajectory traced by point S. Point S is a point in space connected to this coupler, which is attached to the crank and to the slider, and the points, the actual components of this point, can be calculated using these 2 equations. In order to find the velocity analysis, in order to find the velocities, we have to differentiate the position vectors, and then we will end up with these matrices. And in order to find the actual omega, the term J and M are given by this following, because our link to is the input, and we do that. This is the graph that we obtained about our calculations, which represent theta 2 versus omega 3. And then acceleration analysis, after differentiating the velocity vectors and doing some rearrangements, we'll get these two matrices, which again can be calculated using matrices, and the values of J and M are given by these two numbers because our link 2 is our input. And this again is a graph for theta 2 versus the angular acceleration theta 3, double dots. And application of the mechanism. A sliding car mechanism can be found in many applications in our daily lives, such as engines, hydraulic shaft puller, and the ping-pong table linkages, among others. In our practical application, we chose to utilize the windshield wiper of a car. Here we used a rod, a crank, which is how it's called in the industry, and a connecting rod in order to move the wiper in an oscillatory motion to simulate the real application. This is the animation that we just designed. This is this is the crank. This is the actual connecting rod. This is how it moves in oscillatory motion. I'm going to introduce my teammate Chris, which will be talking about 4-bar synthesis of our mechanism. Thank you so much.
Thank you very much. A little bit more on the 4-bar synthesis in this project. For this one, we modeled the damper system of a door. This is its regular system you could see on most doors in any buildings that are used when are closing doors to cushion the close. Dampers are used in many other applications, probably one of the most common ones in motor vehicles. Some advantages and disadvantages of using dampers. As I said before, it cushions the door when closing, so to prevent any noise of the slamming, so it could, for people who may be inside the room or outside the room, to not cause any distraction or disturbances. Also, if the door is set inside a frame or supporting sides of it that is not too sturdy, the infrastructure next to it is not too sturdy, it may be a bit old, or whatever the case may be, this is a good way to prevent any damages occurring to the wall from the constant closing, opening and closing that will keep hitting it. So this is a good way to cushion it and to reduce the amount of wear and tear you get from that. 4 bars are also implemented in other things, most famously in bicycles, in train wheels, and as well as mechanical pencil shavers. Some of the equations we use for this portion of the experiment. The first up here you can see the coordinates. These were given to us on this project, and then we use the formula that we used throughout the semester to get the further points. Then we use the formulas again for the R's, for the lengths of the bars. These will later be used in our SolidWorks calculation and our design to model our part. And lastly here, you can see a simulation of our final product here. So yeah, this is a little bit of the motion study. And here you can see 2 bars. These 2 bars were used just for visual purposes, so you could actually see the door opening and closing. But in reality, it was really, we had 1, 2, as well as a 3rd bar along the door and a 4th one along the wall. And this is really just because it's a 4-bar mechanism, so that's the whole reason we chose to do this device in the first place. Okay, that's it for our presentation today. Thank you very much.